Formula One is constantly at the forefront of innovation. These cars are, without a doubt, a marvel of mechanical and aeronautical engineering. A breakthrough that created quite a controversy in recent years has been the diffusers. Initially introduced in the late 1970s by an engineer of Team Lotus, the diffusers brought back the glory days of the British team, helping them win both the Drivers' and Constructors' Championship in 1978. But actually, what is a diffuser, and how do they work? Increasing tire grip is one of the main goals of a Formula One team. There are many factors that affect the traction of a car, such as the compounds of the wheels, the weight distribution, and the aerodynamic grip, or downforce. Today, we will focus on the last one. As we saw in previous videos, this is an airfoil, and it's responsible of generating lift. During the 1960s, several engineers discovered that the same shape that lifted an airplane could also increase the traction of a car. By just inverting the shape of the airfoil to create a low pressure area at the bottom surface and a high pressure at the top, the aerodynamic force was directed towards the ground, and therefore increasing grip. This discovery was simply brilliant. At the 1968 Monaco Grand Prix, Lotus claimed their victory with their groundbreaking design of the Lotus 49B, the first Formula One car to feature front wings. However, their advantage didn't last very long, since many other teams of the grid started to include wings on their new designs. A decade later, Team Lotus made yet another great discovery, the diffusers. This modification consists on placing ducts under the car that, in the same fashion as wings, increase the downforce of the car. To understand exactly how they work, we must first explain two aerodynamic phenomena, the Venturi effect and the Bernoulli's principle. Let's imagine a canal, like the ducts under Formula One cars. The Venturi effect then states that when we decrease the canal's cross-sectional area, the fluid traveling through will accelerate. This happens because the mass flow rate of the canal, which can be calculated with the following formula, the density of the fluid times the cross-sectional area of the canal times the speed, must always remain constant. In incompressible flows, such as in Formula One, air density is practically constant. Therefore, the two remaining variables that we have left are the speed and the area. If we decrease one, the other increases. The goal of a diffuser is then to increase the airspeed at the bottom of the car. But for what exactly? This is where Bernoulli's principle comes into play, which states that the kinetic energy, potential energy, and pressure of a fluid must always remain constant through a current. When we increase the airspeed of a fluid, or what is the same, increasing the kinetic energy, the fluid also suffers a drop in pressure, since the sum of both must remain constant. This decrease in pressure then generates a suction force to the ground, which at the end increases downforce. This new discovery also seemed magnificent, at least at first glance. One team even took it to the extreme by adding a turbine to the rear of the car, which will reduce the pressure even more. However, and as with any invention, diffusers also had a major drawback. Due to the increase of grip, race cars started to go faster, which put the safety of the drivers in question. In addition, as soon as the car lost contact with the ground, the effect of the diffusers disappeared completely, which made cars very unstable. It was for these reasons that in 1983, the International Automotive Federation, or FIA, decided to limit the use of the diffusers to the rear of the vehicle, and these were replaced by a flat underbody, which remains in place to this date. Later, in 2009, diffusers had an unexpected comeback when several teams of the grid created their own interpretation of the FIA regulations, which allowed them to add another diffuser on top of the already existing one, creating the famous double diffuser. This new device gave the teams of Brown GP, Williams, and Toyota a considerable advantage, since the double diffuser further increased the grip of their cars, allowing them to go half a second faster every lap. In the end, The FIA allowed the use of the double diffusers in the 2009 and 2010 seasons, but prohibited them in 2011. Today, we face yet another problem. Car wings, whose main purpose was to increase the grip of racing cars, also have a major disadvantage. Wings of either aircraft or cars create turbulent wakes and disrupt laminar airflow. This makes chasing and overtaking even more difficult in Formula One, as the wings of the chasing car lose a lot of performance when they encounter turbulent flow, compared to clean laminar flow. For this reason, the 2022 FIA regulations will allow the design of longer diffusers, with a similar size to those of the early 80s. Finally, after 40 years of changes, diffusers are returning to Formula One to facilitate overtaking, increase competition, and most importantly, make racing more exciting.